after you guys copy that. Absent, present, 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 present. Nope. 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 Hmm. Nope. And that's it. Oh man, I didn't need to do that. Shoot. Ah. Everybody done? Anybody still copying? Still copying? All right. So we already did part of this, so it'll be pretty fast. Normally, we would have to come up with a table of X and Y values. When you create the line, oh, wait, what's our first step? I always jump to creating a line. What's the first step? Just copy it. So is it dashed or solid? Which one? Whatever you pick. It's solid, right? This symbol means it is a solid line. Oh, no, not this one. I don't understand it. There. Do it again since it's already messed up. Nope. Right. So we've already done the part where we come up with some numbers, some values, X and Y's, that make the left side equal the right side. Oh, so let's write this, just so we remember. I would write it on the paper so that when you go to actually draw the line in, you remember to make it dashed. Oh, I don't know why I wrote dashed. Solid. So whatever you, like when you do that first step, write it down so you remember when you create it to make it, I mean, you'll automatically make it solid, so you really just mainly need to write if it's dashed, if it should be dashed. All right, so we would normally say, well, what if X was this number, and then how many honey buns could we get? We can't actually do that in that one because it'll come out to be a decimal, and I don't want that. No. I don't know why my board sucks so bad. Try it again. Hopefully that fixes it. So we could say, how about if X was 1? Make me cry. I don't know how to get rid of that. Try it again. X was 1. There we go. So if x was 1, 1 times 1 is 1. I would subtract this from both sides. If you don't follow this, you should know how to do this, but subtract 1 from here. That would be 14. Divided by 2 would be 7. We actually already came up with that. 7 honey buns and 1 airhead. This makes the left side equal the right side, right there. That combination. I just did it again to show you. I'm going to use the same 3 we came up with. What if I did 5 airheads? Well, if this is a 5, 5 times 1 is 5. Subtract 5 from both sides. 2y would be 10. Again, when we create the line, you may want to make this little note next to that second step. When you create the line, you're treating it like this is an equal sign, because the line is the values that make the left side equal the right side. It's the shading that we do that takes care of the less than or greater than symbol. The line will always be the left side equals the right side, just like when we did it before, when we did equations. So that would be 5 and 5. Again, we already did that when you guys first gave me values. You gave me a bunch of values at the beginning that made the left side equal the right side. Finally, we can go ahead and say, well, if it was 3, 3 subtracted from 15 is 12. 12 divided by 2 is 6. So you gave me all of those earlier. So that's why I went through it pretty fast. All of these values land on exactly $15 if he goes in and buys those. Those values are all on the line. The line is spending exactly $15. The amount he spends would equal all $15. So we can create the line using those 3 values. You'll see they'll line up perfectly in a straight line. So 5 and 5 would be right here. What's the next one? 6 and 3 would be right here. And 7 and 1 would be right here. If I now connect those, we would have, I'll do my best to make that pretty straight. Oh, what did I do wrong? Totally did something wrong. You guys gotta watch me. Nope, did something else wrong. What's the first point I was supposed to plot? What did I plot? I've reversed it. I made the 7 the honey buns, and I made the 1 the airheads. That's not what it is. The X is airheads. So I got to go backwards, which is pretty easy. I would like to say I did that on purpose to see if you were paying attention, but I didn't. I just messed up. So I need to be saying X is 1, and then Y is 7. And then 5 and 5 actually was still right. I didn't need to change that, but oh well. And then 3. Yeah, X is 3 and 6. So you'll notice they still are in a straight line, and they should be. So now I can draw a line through those. So it'd be from about there, all the way out to about here, I think. Yeah, that's pretty good. And we'll slide that down. There. So there's the line. Again, we already know it's solid because we did that first. And the reason it's solid is because we can spend exactly $15. That's what that line represents. Spending exactly 15. The amount of money we spend on the left is exactly 15 on the right, which we said is true. We can spend $15. That's why the little equal to sign is there. Now we got to figure out one side of that line is the side we need to shade. It's the solution side. It's all the possible combinations of airheads and honey buns we could buy. You should kind of already know it. Which side is it going to be, above or below it? It's got to be below it, right? Because we know we could spend 0 money. Like we did that one. That was one of the ones I wrote up. We know we could buy 0 and 0. We know we could buy 1 and 1, 2 and 2. So this is an easy one. We really don't even have to test it out. You should just kind of know it if it's a word problem. But the way you test it, so step 3 when you're doing your graphing today, you plug into the equation 0, comma 0. So you're making x 0. So I'm testing this point now, 0, 0. This point right here. 0, comma 0. I'm always going to test that point unless that point is on the line. I have to test a point not on the line. It's got to be on one side of the line or the other side. Plus 2 times 0. And then I need to see, is that less than or 15? Less than or equal to 15. Will that be a true statement when I do the math? Well, pretty easy math on that side. That's why I picked 0, 0. Oh, I'll tell you this when we do the lesson on Friday. So is it true that 0 is less than or equal to 15? Is that a true statement? Yeah, sure. 0 is less than. It has to be one or the other, either equal to it or less than it. Yeah, that is true. Absolutely. So if we get a true value when we test that 0.00 out, then that's the side we shade. Now, in this case, we would only really shade all these positive values because you can't buy a negative number of airheads or a negative number of honey buns. When you graph today, though, on your worksheets, you would have to draw a line across the entire graph, and you'll shade the entire, like one of the entire sides, either above or below the line. Again, for airheads and honey buns, we can't really use negative numbers, so there's no reason to shade in the negative numbers. So that's an example of graphing and doing a word problem. The graphing is what you do on Monday. The word problem part we'll do it at a future time. Oh, all these values, by the way, we could check and just make sure that all these, oh, actually, here's your last part. This is the easiest question with this. I'm going to give you a graph. I'm going to do it all for you. I'm going to graph the line. I'm going to graph the shading. I'm going to do it all for you. And then I'm going to give you a bunch of values just like these. So we'll just, I was going to do a whole new graph and show you exactly what the question, I'll do that on Friday. So I'm going to give you a graph. It's all completely done. And I'm going to say, circle the values, circle the ordered pairs, circle the solutions, or circle whatever that are solutions to the inequality. How do you know if it's a solution? What did we say a solution was, an answer was? What did we just do to come up with answers or to test 0, 0? How do you know if something is a solution? This is way back when we did equations, but same concept. The answer to a problem does what? If it's an equation, it's a little different. You'll hopefully remember. Does what? If it's an equation, it makes the left side equal to the right side. That's what we said. In an equality, it just makes it a true statement. The left side, in this case, needs to be less than or equal to the right side. If the sign was flipped, then you'd have to say it a different way. So if it's truly an answer, it will make the statement true. We'll just call it a statement. The rule, it'll make the rule true. Because this is still a rule. It's just the rule now involves less than or equal to instead of just equal to. So all of these values should work because we came up with them in our real life scenario. So all of these values, if we plug them in, should make the left side less than or equal to. We can try it out real quick. 3 airheads would be $3. So if we plug in 3 for X, here, I'll just redo it. We already did 0. So we already did 0, 0. 0, 0 was true. So if I plug in 3 and 1, well, 3 would be 3 plus 2 is 5 less than or equal to 15. Yeah, 5 is less than or equal to 15. Everyone you test that you know works should make the left side less than or equal to. Let's take one we know doesn't work. Somebody said earlier, I just wandered around, that, what was it, 6 and 6 or something like that. And then we said, well, that doesn't work because 6 honey buns would be $12 plus another 6 would be 18. That's too much. Well, let's test it just to show you that we were right. So if I said 6 and 6, that we'd have to plug it in and see if that made the left side less than. Well, no, 6 and 6 doesn't work. That's how you see if something works, right? You plug it in and see if it makes the rule true. If it makes the rule true, then it works. If it doesn't make the rule true, it doesn't work. It's even easier now. If I give you a graph, and this is why graphs are so valuable, you don't have to do any of that. If the point is in the shaded area, it's a solution. That's what the shaded area is. The shaded area is a solution. If the point is on a solid line, so you need to write this part down. If the point is in the shaded area, there's going to be 4 things. So you can make them bullet points. If the point is in the shaded area, it is a solution. That's what the shade. That's why we shade that area, is because that's all the solutions. That's the whole point of shading, is to show where all the solutions are. So if the point is in the shaded area, it is a solution. I said this is going to be the easiest question. There is absolutely no calculating involved. You just have to remember these 4 things, really just 2 of them. If the point's in the shaded area, it's a solution. If the point is on a solid line, so this line's solid, so if the point is on this line, it is also a solution. So if the point is on a solid line, it is a solution. Really, that's all you need, because anything else is not a solution. I'm going to give you 2 more just to make it really clear. If the point is on a dashed line, it is not a solution. So if this line were dashed and we used a point on it, that would not be a solution. The line is, that's why we make the line dashed, is to say, yeah, these points on the line are not solutions. And we do that whenever we have these 2 symbols. There's no or equal to part underneath. That's when we'll make a dashed line. And then the 4th point would be, if you haven't already figured it out, if the point is in the unshaded or not shaded, whatever makes more sense to you, if the point's in the area that's not shaded, it is not a solution. So if you just remember those 4 things, that should be the easiest question I've ever given. There's no calculations involved. You just got to find, well, again, you have to know how to find a point on a graph. So you got to know x is first, left and right first, then up or down. So 3, this would be 3, 6 if I made it a point, 3, 6. If I said, actually, I want you guys to think about, is the value 8 airheads, so x is 8, y is 3. Is that, don't say it out loud, I want everybody to think about it. Is that a solution? 8 airheads, 3 honey buns. Is that in the shaded area, or it could also be on the line since the line is solid? So 8, 3. 8, 3. 8 is your x, because that's the airheads. 3 is the one on the quiz will not be a word problem. I'll just give you an ordered pair. So I would give you this, and I would say, is this I'll give you more than just one, but I would say, is that a solution? And you just have to find it on the graph. If it's in the shaded area or if it's on a solid line, it is. Otherwise, it's not. So look at where you think that is. Raise your hand if you think that is a solution. It is a solution. 8 is the x. 3 is the y. So it's barely a solution, but it is a solution. If it's barely a solution, that means we're really close to spending $15, but we're still less than 15. So 8 plus 6 would be 14, so we're $1 away. If it's way down here, it means we're not anywhere close to spending 15. The farther you are away from the line means basically the less money you're spending. The farther away you are from the left side equaling the right side. All right, so here's what you're doing today. You're using these 3 steps. You're graphing you do have to create a table, so I'm going to go back over how to do that real quick. Don't worry about, oh wait, I'm sorry. I'm wrong. Here, we'll do this one right here. Actually, I'm going to do two of them. We're going to, no, I'm not. We're saving those for tomorrow. So let's go so we'll do number 7. This is not your sheet, so I'll tell you what, I do want you to go ahead and do that then. So I'll give you graph paper, write that equation when you get the graph paper. Actually, say what you got. Side 1. There you go. Just pass it around. I'm not going to walk around and hand it to every single person. So some of those will need to go over to Justin and to. I'll walk back and get it to you. If you have extras, just put them on an empty desk book beside you. So write down 5x, subtract y is greater than or equal to 5. Now, the other class really struggled with this, but I also don't feel like they paid attention at all or wrote anything down. So please make sure you. Yeah, just put it on a desk around you. You put it on the cabinet. All right, so when we graph any inequality, any equation, we can always do it this first way. We're going to do it a second way on Friday, using, like, for some of them we'll use the rise and run and slope, all that stuff. But this way works for every single inequality or equation. We just create a table we got to find 2 ordered pairs that make the left side equal the right side. What's our first step though? I always want to do the second step first. Yeah, so is this a dashed or solid line? Solid. If it's got this little guy, it's solid. So just go ahead, write solid. Again, normally you're going to draw a solid line anyway, so it's not as important to write solid as it is dashed. But just, it's worth doing it just so you get in that habit of writing it dashed when you need to write dashed. So now we did that. Now we need to create the line by thinking, okay, this left side has to equal the right side. I just need to come up with an x and a y that will make the left side equal the right side. I want you to try to come up with those on your own first. Are we allowed to beat kids? I really feel like I need to beat them. This one's pretty good, though. I don't know what's going on with this one. She's going to be our next superstar. Hey, I thought she would have figured it out from last semester when I was already talking to her about this stuff. Get in. Get in. Hey, that's baby steps, I guess, for you. You're relatively on time, too. Were you on time to your first class?
Yeah.
All right. Did anybody come up with 2 of them? Right, and again, you don't have to tell me them. We're going to do it together. But raise your hand if you're like, yeah, I got 2 ordered pairs. I already got the line. Good. All right. Anybody else? Think so? So let's go slower then. That's what I wanted to see. If I want to come up with an x and a y, I could just try to guess. I could plug in x. I could just say, oh, well, I'm just going to plug in a bunch of numbers. Let me try 0, 0. Well, if I put 0 here and 0 there, does that equal 5? Because again, I'm ignoring this. When I'm creating the line, I'm thinking of it as that, when I'm creating the line. We'll deal with that greater than or less than part when we shade. So the greater than less than part is only for the shading. When we're creating the line, we think of it as equals. Well, is 0 equal to 5? No, 0, 0 doesn't work then. Because 0 subtract 0 would be 0. That doesn't work. I could do that forever and plug in random numbers. as you hopefully can guess, that's going to take a long time to get lucky and come up with the right ones. It's a lot easier to just pick an x, any x you want. Does not matter what you pick for the x. The key is you have to solve for the y. That's the key. Some kids are still just like guessing both numbers. So I'm going to pick 0 because 0 just makes my math really easy most of the time. Anytime I pick 0, normally it's going to make a part of the equation go to 0, like right here. That's going to just go to 0. So that's why it makes my math easier. So subtract y, again, I think of it as equals. So now I have 0 subtract 5. I'm sorry, 0 subtract y equals 5. Now here's the weird part. The 0 just always goes away. Anytime you have 0, unless you're multiplying. If you're subtracting or adding, the 0 just goes away. So we have negative y equals 5. We don't want negative y. We want y. We want the variable y. So there's a couple ways you can do it. I'm going to give you the cheat sheet version first. Anytime you have a negative variable and then a number over there, you can just move the negative to the other side. That's basically what winds up happening. I could just say y equals negative 5. If negative y equals 5, then y equals negative 5. Here's why you're doing it. So if this helps you understand, it's really negative 1y. There's a 1 in front of that y because there's one y. Like we see a y. There's one of them there. We don't need to write 1 because we can already tell there's 1 there. But technically, you're saying that's 1 negative y. Because remember, we said the number in front of a variable means that's how many variables. That's 5 x's. Well, this is 1 negative y. That's 1 negative y. So when I'm doing the steps, I would really be... I would be dividing by negative 1 on both sides, which is what gives me y equals negative 5. That's the math behind it. Again, if you didn't follow that, if you're struggling with equations and graphing, just remember, make a little note. If you have a negative variable, now if this was negative y is negative 5, you'd have to flip the sign. You'd have to say y is positive 5. So if this was negative, you have to flip that. You can't just leave it as negative. So you're always going to flip the sign. So now I use 0. I got negative 5 over here. That's the first point I can use. Now pick another x. Or sometimes you may want to pick a y. Picking a y might be easier. Any questions on that one? Sometimes picking a y value is easier. Yeah, we'll do it that way. Sometimes picking another x is easier. Sometimes picking a y value is easier. I'm going to pick a y value just to show you how to do that. And I'm going to pick 0 again. Again, 0 makes my math pretty easy. So I'm going to say, well, what if y was 0? What would x have to be? I can pick anything I want for the first variable, but then I have to solve for the second variable. Well, that would be 5x, subtract 0 equals 5. Well, again, we said if we're adding or subtracting 0, it just goes away. 5x. So if y was 0, x would have to be 1. So pick a number for the first variable, and again, you can pick for x or y, then solve for the second variable. So now that's all I need. I only need to do that twice. So now I'm going to plot those 2 points. Then I can draw my line. I know it's solid, so I won't have to change anything. So let's see. What are my points? 1, 0 is here. 0, negative 5. I'm going to scroll down a little bit. There. 0, negative 5 is down here. Those are my 2 points that are on the line. I can go ahead and draw a solid line through those, which I've already done. Hey. So that's step 2. We created the line. That way works for every possible inequality or equation. Now, sometimes the math is tougher. You might get decimals or something when you do it, but it will work for everyone. We'll learn on Friday, or we'll review, because we've done it before, we'll review how to do it using slope-intercept and the rise and run. I'm sorry, the y-intercept and then the slope formula. That only works in certain situations, though. So we'll go over that on Friday. That's why I didn't do that one first. This works for any equation. You can figure out 2 ordered pairs that make the left side equal the right side. Now we need to shade. What do we do to shade? What was the 3rd step? We test 0, 0. So if you don't understand what testing 0, 0 means, you need to write some notes by that 3rd step. We're going to plug in, so that's 0, 0. At 0, 0, x equals 0 and y equals 0. It's the origin. That's what 0, 0 is. X is 0 and y is 0. So we're going to plug in zeros for both of the variables and see, and now we need to go back to the correct symbol because we've done the line. Now we have to use that greater than or equal to part. 5 times 0. So again, I just plugged in 0 for x. This is what testing 0, 0 means. Subtract 0 greater than or equal to 5. And I do the math and I see if that's a true statement. If it's a true statement, then that's the side I shade. If it's a false statement, then it's the other side that I will shade. Some kids every year just always shade where 0, 0 is. That is not correct. It's not always where 0, 0 is. So 0 subtract 0 greater than or equal to 5. So 0 greater than or equal to 5. Is that a true statement? No, that doesn't work, right? Oh, so no, I need to write. So we would say no, that is false. I would actually write true or false by it. Because for some reason you made a mistake after that. But I saw that you did that step and then wrote false. I could say, all right, well, I mean, they somehow messed up the last step when they shaded, but they told me that wasn't a true statement, so I can give you a little bit of credit. So if it is a false statement, that means this does not work. 0, 0 is not a solution. If it's not a solution, we can't shade that side. The side that isn't solutions is the unshaded side. We said all the solutions are in the shaded side. Well, that means this has to be the solution side. It's all or nothing. You can't have some solutions on one side and some on the other side. So I would come up and I would shade this side. So all of these should work. Now, just to make sure, I'm going to pick a point in that shaded region and just make sure that it does work. So I'm just going to pick, this is going to make my math pretty easy if I pick 2, 0. So I'm going to say 5 times 2, subtract 0, greater or equal to 5. 10 subtract 0, greater or equal to 5. Is that a true statement? Because it better be, because it's in the shaded region. Now I'm really confident I did it right, because I picked a spot on the other side and it did work, which it should work. All right, so go ahead, I'm going to tell you specific ones, because some of them we'll do on Friday. Or some of them just come out with decimals, actually. That's right. So do number 1, number 3, number 5, 1, 3, 5. And then on the back, do 10, and you should have already done this one, but if you didn't, 12. So just 5 graphs. 1, 3, 5, 10, 12. Yeah, that'll be it for today. And we'll go over the other types. I'll probably have to print another sheet because you're doing some of the ones that we would really need to do on Friday, but there weren't. I didn't want you to have to deal with fractions today. So 1, 3, 5, 10, 12. I'll walk around and help. If you can do that today, you're in good shape already for the quiz on Monday. Friday will just kind of be a bonus practice day. Oh, which numbers? Like you're talking about the numbers you're supposed to do? You do not write them down. Oh, I don't have the worksheet on the screen. Because if you want to see the actual problem, I don't have. You don't have your worksheet? Interesting. Because there were a bunch of people that left worksheets in here.
I did not.
Monday, so you didn't have that bent up one.
I did not. Mr. Gill, for the X, do you always want them to start out with 0?
I do not for this part. I'm not doing intercepts.
Okay.
We did intercepts when we did. Again, I told them 0 normally works out better.
Yeah.
So for X, I would say, yeah, you're pretty much always going to want to start with X equals 0. Like your first step once you create the X and the Y part. So like if I were doing this problem over here and I wanted to create a table, I'd pretty much always start with it. Like there's no reason not to do that really, unless you get really advanced at math and you can just look at the problem and tell that's not the best number, but pretty much always do that. Whether or not you pick a Y of 0, that's kind of up to you. It's not always, I mean, it's never necessary, but sometimes that'll be easy, sometimes it won't. Well, then you get illustrations, that's not the problem. You have the equations, you wrote the equations.
No,
You need more. File, you don't have 3 graphs.
Well, one of the folders in here.
Oh, actually, I did it all. Yeah, I was going to say I just gave it all out. So 1, 3, 5, 10, 12. You were here. Yeah, I do know. You left it in here.
So yeah, some people put them up here, you know.
Why do you guys not have your papers? You weren't here Monday? Then you're forgiven. But I know a bunch of you left it in here. I collected like 5 or 6 of them, the people that left in here that day after class. So that's why a lot of times. Oh, I don't know what happened. Yeah, you left it in here. You never took it out with you. Didn't even ever write your name on it. Where are the other, like when I passed out graph papers earlier, there were leftovers. If you can do it on this. I'll write all the, I'm going to write the problems up on the board for those of you that were here and lost.
Well, I got it.
Well, no, you're going to need more because there's more than 4 problems you're going to have to do. Nobody needs this anymore, right? Shouldn't need that. All right, so here I'm just going to write the inequalities off of the sheet. These graphs are actually easier anyway because they're a little bit bigger. Because I only made enough copies for, I don't even make enough copies for everybody anymore because I don't have everybody show up. So these are the ones you're doing. Oh, actually that doesn't have all the problems on it. So number 1. Yeah, just write this over one of the graphs and then you can do it. These are not the numbers on X here. Number 3. Then number 5. What was the other one? 10. You should have done 12 the other day, so you might have already done 12. So for those of you that don't have your sheet, if you need another page of graphs, give you one, but I don't even print enough. I don't print enough worksheets anymore for the entire number of kids that I have because not everybody shows up. I'm killing too many trees. All right, I can do that. I can probably do both of those at the same time. Okay, so let's talk about this. This would not be right here. I want you to show me how you came up with 0 and 3. Where's the work that you did? I don't see any work at all. You can't just randomly guess. You got to solve it out. Let's solve it out. Erase that. That's too close for the just exactly. She's doing some work right now. Yeah, if those were your points, I can't get right. I used to get them at golf tournaments all the time. Brand new one. Although yours, I will say yours is probably. Oh yeah, I do have a couple metal ones, but those have actually. I'll be back there next. All right, so you're both doing that one. So let's do that one together. Actually, you do that one together with them. So all three of you. So do your XY table chart thing. And then that is for all of your tables should look just like that. We're always going to start with 0 as the first X value. We're gonna do that together. Waiting for everybody to get to the same spot, so I don't have to say the same thing. So what's the first thing you need to write under the X column?
Stop. Why are we writing 0?
Because 0 makes our math easier. We could have written 10. We could have written 100. But 0 is going to make our math easier every time. All right, so if we're going to say, so here's what we're basically saying when we're doing what you just did. We're saying, what would y be if x was 0? So if we want to know what y would be if x was 0, then we have to make x 0. We have to, in the actual equation or the inequality, we have to make x 0. So we can figure out what y would need to be. So rewrite the equation, or technically it's inequality, but we're really going to think of it as an equation for right now to create the line. Write the equation, but instead of writing 3x, what would we write?
0.
Well, we'd write 3 times 0. Technically, there's no go to 0. I want you to write all the steps out.
I don't have enough room.
Well, then use 2 pencils. You can do it right here. There's plenty of room, because you're not even using every graph, so for some of them, well, whatever the, I don't have my, whatever the 3 is in the equation, in the inequality, that's what you're writing. You're just changing x to 0. So you got y equal, well, it doesn't have to be equals, but basically it's, we're saying y equals 3 times 0 plus 1. Negative 3 times 0 plus 1. So that's what you should have written down. Yeah, you have, I said exactly what you just wrote. You've already done the next one. So, oh no, but then plus 4. So you need to write y, like write it all. Like you write everything else. Nothing else changes. Then you just do the math. Now just do the math on the right hand side. Now just do the math on the right hand side. You got all numbers on the right hand side. So what would, and again, we're thinking of that as y equals 4. So what's y? That's how you solve this.
No, you made it step by step.
Because I don't want to have to come back here and do that same thing over again when you don't know the steps.
Okay. What's negative 3 from here?
You're just doing the math on the right. Do the math on the right. Just look at the math. You got all numbers. How do you do that math? So what do you get? So what do you get? So you get 0 for the first part, then what do you have to do? So what do you get? Thank you.
See, why?
Because I guarantee you I'd have been back over here again if we just skipped straight over. We tell you to solve. Yes. What it literally says y, although it should say y equals. So that's your first point. Now you got to choose another value. You could choose a value for y, or you could choose a value for x. You know you can't pick two numbers. This is what kids. So again, I'm going to say it again. When I know you didn't make me mad. I said this earlier. Write this down because if one more person does it, I'm going to beat you. I might get fired, but it's going to be worth it. It will be worth it to me. It will. I know. I'll get fired. I know I will. It will be that worth it if I get this question. You can't just randomly pick two values. Say, I'm going to try those two. You cannot do that. You pick one number, either x or y. You plug it in to the equation, and then you solve for the other thing. We just did this twice. I mean, just what? Actually, we've done it a million times. We did it in a whole other part. You can't, like, write a note. You cannot just pick a random value for x and y. You pick one of them, and then you solve for the other one. So you could pick 3, but then you have to plug that in and solve to see what y would be. I know. I got who's on? In the middle of who's on? You're cold.
You just worked yourself up. That's why you're hot.
Actually, you're right. I do work myself. You cannot work me up. I have to work myself. You don't control me. You can't make me mad. So I work myself up. You're correct. Nobody can make you mad.
I do one thing
Because you guys need it. Every once in a while, you guys need a good lecture. You need a good lecture.
So look at how we solve this.
Yes.
That one back there.
So, I have an exception because I'm sick and my grade.
No, incorrect.
Wait, so.
Oh, you got to think about that because I can already tell that's a bad question. Girl, I just went over. You didn't write it down.
I'm so cool.
Here. What did I just say? First thing you picked earlier. So you can always write this as your first step.
Wait, what if I ask one?
Not that you don't understand it, and that you're not paying attention. I just said write this. You could have written it whether you understood it or not. I said your first number you should always pick because it's going to make your math easier. That's the beginning of your problem every single time. Every time. No exceptions. If you really were fantastic at math, then I wouldn't say that. But we're not. So start with that. Now you need to plug that into the equation. So take the x out, put that in, and then do the math. Figure out what y would have to be. If you have one variable in one equation, you can solve for that variable. So once we change x to a number, we can solve for y. Normally it's pretty easy to solve for. I'll come back and check what you get from y before you move on.
This doesn't make any sense.
One problem. Write one of those down. Yeah, do number one. Number one will take you that long. At least show me the math to solve out like this. I want you to create 2 ordered pairs. If you do that, I'll let you go.
I'm over this. It's a good one. You pick that up. Why am I so stupid?
It's pretty symmetrical.
Can you pick one up?
None of you are stupid. That's what makes me. If you're stupid, I wouldn't care. Oh, it's okay. Hey, honey, don't worry. I'd be like that if I thought you were stupid. Anyway, I don't mean you. I mean like any of us. None of you are stupid. You just don't pay attention. You don't try.
I was answering questions.
You don't, girl. Even you don't pay attention. You ask a bunch of questions. I'm like, I just.
No, we did before. I will admit I was zoning out.
Again, I know you guys do. Like I know you do. Like it's.
I have
None of you are dumb.
disorder.
I rarely ever have a kid that's just super attentive and trying and just can't get it. I've had it. It does happen. And that's how I know the difference between kids that are just tuning out and kids that really can't get it. But I have had one or two that just they just can't get it. You figure out the first value?
Yeah, I figured out the first value.
Well, this is -3 times x. So it should be -3 times 0. Remember, if you have 2, we haven't talked about this in a long time, so I'll remind you. If you have a number next to a variable, what's that mean? What math are you doing? All of those, you're multiplying. So when you plug the x in, plug in 0 or 1 or whatever, you're then going to multiply those two things together. So if I plug in 0, that is 3 times 0. If I plug in 0, that is 2 times 0. Whatever number I plug in, I'm multiplying those two things together. It also means x plus x plus x.